Okay, let's give you guys some more practice. So here, find the linearization of f of x equals 1 plus x to the power 3 at x equals 0. Meaning, find the equation of this tangent line here, passing through this particular point. So you will ultimately need to find out the gradient at this particular point. Okay, so press pause and have a go. So to do this here, start out with your f of x equals this thing here. So start out with f of x. So start out with f of x equals that thing there. Okay, so remember you need to find the gradient at x equals 0. So start out with this, differentiate it. It will then give you this. Okay, but then you need to know the gradient at x equals 0. So you put 0. You put 0 into this thing here, giving you this whole thing here. So the gradient at x equals 0 is given by 3. So now that we've got our gradient being 3 here, remember the equation of our tangent line is given by this. Okay, but because we are evaluating it at x equals 0, then that will lead us to this. Okay, and don't forget this bit here is this 3 here. It's what we worked out. So we can put a 3 into there. So this whole thing here boils down to this. So this is the equation of our tangent line here. So now get yourself a graph plotter, plot the original function, and then plot our approximation, plot our linear approximation here. That will give us this blue line here. So the red line here is the red line here was our original function. This blue line here is our linear approximation. So around x equals 0, we can say that the blue line is approximately the same as the red line here. Okay, so we can actually make this statement. We can actually say this here is approximately the same as this. Well, when x is near 0. Okay, meaning that whenever this number here is a small number, let's say 0.37 or something, or well, whenever this number here is quite small, then we can say that this whole thing here is roughly the same as this. You can see that this here is a lot easier to work with than this. Okay, so this one here will around x being near 0, we can say that this thing here is approximately the same as this. Now, if you follow the same process through again, but with this x to the power 1 plus x to the power of 2 here, the approximation, our linear approximation near x equals 0 is this. Now, if you follow the same process again, but with to the power of 5 here, our linear approximation will be this, near x equals 0. So in general, if you have something to the power of r here, the linear approximation to this thing here is given by this. And bear in mind that it will be near x equals 0. Okay, so whenever you have some 1 plus something, but this something here is a small number, and then to the power of r, then that will be the same as this here. Bearing in mind that this needs to be near 0 as well. Okay, so in general, this is actually quite important here. Okay.